So we have the equation which says two forces act on a pipe as shown in figure 1. Specify the direction of F2 so that the resultant force acts in a positive y direction and has a magnitude of 850 newtons. Okay, so the first thing to do is to outline the free body diagram for the figure. So this is actually a three-dimensional force, as can be seen. So the free body diagram already is seen. This is Z direction, this is the X direction, and this is the Y direction. So we got the same way you see it. This is your Z direction, this is your Y direction, and this is your X direction. Okay. From the origin, we have a force of 650 newton F2. So now F2 is 650 newton equals 650 newtons. We also have F1 350 newtons. So we have force F1 equals 350 newtons. The angle between force F1 and the x-axis is 40 degrees. So from here is 40 degrees. The angle from the z component down to F1 is 120 newtons. So from this point is 120 degrees. And the angle from y to x F1 is 65 degrees. So angle from there to this point is 65 degrees. Question says we should specify the direction of force F2. Direction simply means the angle of force F2. So if from this point to this side is 120 and we don't know this angle, this is the direction of force F2. So let's call this angle alpha, that's the direction of force F2. Let's call that direction alpha. Okay. Let's also say please watch, if from this point to here is 120 degrees and from this point to this point is 65 degrees, it actually means from here to this point alone is actually 120 minus 65. That will be what the angle from here to this point. So 120 minus 65 is actually 55 degrees. So we need the angle between y and z is 45 degrees. So to call here alpha, let's call here theta. Angle which is force F to make to the vertical. So it actually means alpha plus theta should be equal to 55 degrees because this angle is alpha, this angle is beta, and from this point to this point between z and y is 55 degrees. That's the first thing we establish. Okay? Alright, so let's begin to find the components of the forces. Let's start with the horizontal component of force. Horizontal force component. Force component or component of force. Okay, let's use S because we have more than this dimension. So let's find the forces in the x direction. So x, the force in x direction. X direction. So we find all the forces in x direction. Let's start with force F1. So F1x. Now please take note, the x direction is also called in vectors is the I direction. Meanwhile, the y axis is in vectors is the j direction and the z axis is the k direction in terms of vectors. So the position vector of force F1x, resolving F1 to the x, hold F1, pull it to the S line, it passes through this angle 40 degrees to get to this point. So you simply multiply this angle by the cosine of this force by the cosine of the angle it passes through. You have the force is 350 cos, the angle it passes through is 40 degrees, so 350 cos 40 in the I direction because x is the I direction. So it means that F1 F1x in the x direction is equal to 350 cos 40. What is 350 cos 40?
268.1155.
Yeah, 268 point what?
11555.
1, 2, so that is the force of F1 in the x direction. Let's find F2 in the x direction. So F2, okay, let's find F1, F2 in the x direction. F2x is given us will give us to the old F2, resolve it to meet the x line. Notice that F2 will move all the way from this point, covering this angle alpha plus 65 plus 40 to get to x. So F2x will give us the force, which is 650 times the sine of the angle it passes through. And the angle it passes through first, you move all the way from here to this point, passing through alpha, and then you move from this point to this side, that's plus 65 degrees from here to this point, also move from here to this point, plus 40 degrees. 40 degrees. Okay? So that means that cos F2 in the x direction, remember x is I, is now equal to that will equal 650 cos alpha plus 65 plus 40 will give us 105 degrees in the I direction. So that is cos F2 in the x direction. Okay? The next is to find y component of force. So let's find the force in the y direction. Y component of force. Are you following?
Yes, sir.
Okay, so let's find the force now in the y direction. F1y, resolving F1 to the y direction. Remember, y direction has a vector as j, that's the vector as j. So resolving F1 to the y, hold the tip of F1, pull it to the y line. It passes through this angle 65 degrees. So you have multiply the force by the cosine of the angle it passes through. That will give you 350 cos 65 to the j direction. That's equal to 350 cos 65.
One 147.916.
147.916.
Yeah.
Okay, so that's the force of F1 and the y. So F2y also hold the tip of the arrow, resolve it in the particular y line, which is in this case is here. So if you pull this force to read the y line, it passes through this angle from here to this point, which is alpha. Multiply the force by the cosine of the angle it passes through. So you're going to have 650 cos alpha, that's in the j direction. That's from F2 in the y direction. Finally, find the z component of force. Z component of force. Okay, still the same thing. F1z, resolve F1 in the z direction. We are going to have hold F1, pull it to the z line. Remember, the angle between F1 and z line is actually 120 degrees. That's from this point to this point is 120. So you're going to have multiply the force by the cosine of the angle it passes through. So you have 350 cos 120. So 350 cos 120 is what? Difference at all. No difference.
Negative 175.
175 in the k direction. Okay. So the z axis is the k direction. Resolving force F2 in the z direction, we are going to have force F2 is here 650. Resolve to be the z line. It passes to this angle from this point to this side. I will define this angle as beta. So it becomes the force times cosine of the angle it passes to get to that particular direction. And the force is 650, the angle it passes to get to the direction is beta. So you have 650 times cos beta. This is the k direction. So having obtained all this, the next thing to do is to find the position position vector, resultant vector, force in vector form. Find resultant force in vector form. So you obtain the resultant force in vector form. Okay, that is simply add all the forces together. That's what it means. So resultant force Fr is now equal to the sum of all the forces. That's what it means, the sum of all the forces. So first of all, we have 268.12 I. So we have 268.12 in I direction plus we have 650 cos 105 or alpha plus 105 in the J direction plus we have 147.92J 14. This is supposed to be I, please. Okay, J, correct. 147.92J 92J. We have that, and then we have plus 650 cos alpha J plus 650. Okay. Please, this is I. This is I. Okay, this is I. Okay, so plus 650 cos alpha J. Okay, plus 650 cos alpha J minus 175K minus 175K and plus 650 cos beta K. Okay, this is what we have. So let's coordinate the unit vectors all together. Let's coordinate the unit vectors all together. So we have resultant force Fr is equal to, this is I and this is I. So we can bring them together. We have 268.12 plus 650 cos alpha plus 105 all into I, all into I, okay, plus 147.92 plus 147.92 minus 650, let me bring that down there, plus 147.92 minus plus 650 cos alpha all into J, and then we have 650 minus 175 plus 650 cos beta all into J. So you can put it plus 650 cos beta minus 175 all into K. So you can write the resultant force like that. But recall from the question, it said that specify the direction of force F2 such that the resultant force is a positive force in the y direction, in the y-axis, and has a magnitude of 850 Newton. So the resultant force is in the positive y direction. And the y direction is the same thing as the j direction. So they've given us that resultant force is 850 in the y direction, that is the j. So this simply now implies that resultant force itself, Fr, is actually 850 j because it's in the y direction. So if it is so, then we can now write this equation to be okay, so we are going to have now that in place of resultant force, we simply put 850J. So we have 850J is equal to okay, 268.12 plus 650 cos. Okay, is equal to 268.12 plus 650 cos alpha plus 105, okay, all in the I direction, plus 147 points, 147.92, 147.92 plus 650 cos alpha, all in the J direction, okay, plus 650, okay, 650 cos beta minus 14175, 650 cos beta minus 175 in the K direction. So having this, it means now that at this point we compare unit vectors, comparing unit vectors. Comparing unit vectors. So we compare the unit vectors on both sides. This is I direction, and on the left hand side of the equation there is no I direction. So it means that the unit vectors in the I direction for the left hand side is equal to 0. That's what it means. On the I direction, we don't have, so on the left hand side of the equation, we do not have any unit vector in the I direction. So if you compare that to this is the I direction on the right hand side, compare that, if you see there's no I here, it means the I direction vector here is 0. So it means now that this equation can be written as 2, 6, 8 points. 1, 2 plus 650 cos alpha plus 105 is equal to 0. All is equation 1. Also comparing to the J direction, on the left hand side of the equation we have 850 in the J direction. Okay, so it means now comparing the J directions, we are going to have 147.92 plus 650 cos alpha, and that's equal to 850 in J direction. So we call this equation 2. Also, for the K direction, there is no direction in the K at the left hand side of the equation. So that means for the right hand side, it's going to be equal to 0. So we have 650 cos beta minus 175 and minus 175, and that's equal to 0. Okay, all this equation. Okay. So if you have this, there are two ways of achieving that result. From equation 3, we can have that 650 cos beta minus 175 is equal to 0. So let's send minus 175 over to this side of the equation. We are going to have that 650 cos beta is actually 175 cos minus cos are equal to 10 becomes positive. So making cos beta something the formula, cos beta is actually 175 divided by 650. So that implies that cos beta is equal to 175 divided by 650.
0.26461.
0.26461. Okay. So that means that beta is cos inverse of 0.264. Okay. So beta is equal to,
Okay, beta is equal to 7.65681.
yeah? Have you taken cos inverse?
Yes.
What do you have?
74.66568.
74.7 degrees. So the value of beta is actually 74.7 degrees. But recall, we said earlier that alpha plus beta is actually 55 degrees. Okay, alpha plus beta is 55 degrees. So that simply implies that alpha plus beta is 74.7 is 55 degrees. So alpha is equal to 55 minus 74.7. Alpha is equal to what is this value? 54 minus 55 minus 74.7.
Minus 19.7.
Alpha is minus 19.7 degrees. But since you can't put your angle in negative form, always add 180 degrees to it. Because your angles are not meant to be in negative form. Whenever it appears in negative form, all you do is to simply add 180 degrees to it and release negative sign. So that's the reason why that alpha is simply minus 19.7 plus 180. So therefore,
160.3.
160.3 degrees is the direction of force F2. That's the direction of force F2.